Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for finding the kth smallest element in the binary search tree. Let's look at the problem description. We are given a root of a binary search tree and an integer k, and we have to return the kth smallest element in that tree. For this tree, we have to return the first smallest element. So in this, among this is the smallest. We have to return this, and in this one we have to return the third smallest element. So among these elements, 3 is the smallest, and the constraints, the number of nodes is n, and k is between 1 to n, and the node values ranging from 0 to 10 to the power 4. Let's see how we can solve this problem. So we have this input, and then we have to find the second smallest element in this tree. So the approach one is we can do the in-order traversal for the entire tree, and then once we get that output as a list, in that the second element we can return. That is one approach. In this case, we have to traverse the entire tree. The second approach is we can do the in-order traversal until we find that the index we are interested in. So for that, we need to locate the first element in the sorted list. So the first element is the deepest left child during the in-order traversal. So, and then once we find that deepest left child, we initialize the index to 1, and for all other nodes we increment the index after processing their left child, and then we check whether the index is equal to the k. Then we return the corresponding node's value and stop processing the further elements. If the index is equal to k, then we return the corresponding node's value and stop further traversal. Let's look at the flow chart. Input for this procedure is pointer to the root, and then the index of the kth smallest element in the sorted array, and then a pointer to an index which keeps track of the relative position of the current node from the deepest left child in the tree. And first we initialize the kth element to -1. As per the problem constraint, the element values will be ranging from 0 to 10 to the power 4 or something. Then we check whether that root is null. If so, we will return. Otherwise, we check whether there is a left child exists. If not, we will skip this recursive call. Otherwise, we make a recursive call to the left child, and with us passing the k index k and index, and then assign the return value to kth element. So once this recursive call returns, we check whether the kth element is greater than -1. If it is greater than -1, that means we found the kth element. So we return. Otherwise, we check whether the index is non-zero. If it is not non-zero, that means this is the first time we see, this is the deepest left child, and we initialize that index to 1. If it is non-zero, then we increment that index and then proceed. Then we check whether that incremented index is equal to k. If so, we return the root value. We find the kth smallest element, so we are returning back. Otherwise, we check the right child exists. If it exists, make the recursive call to the right child and assign the return value to the kth element. Otherwise, we skip that recursive call and then finally we come out of this procedure and return the kth element. Let's move on to coding. First, I initialize the index to -1 and then I call kth smallest helper function. Inside this helper function, I initialize the kth element to -1 because the valid range for the values are 0 to 10 to the power 4. So I choose -1 and then I check whether the root is null. If so, return that -1 as the return value. Otherwise, make a call to process the left subtree of this root node. And assigning the return value to the kth element. If the kth element is greater than -1, then that means we already found the kth smallest element in the left subtree, so we are returning from here. Next, I check whether the index is -1. So after processing the left subtree the very first time we are hitting here, that means that we are hitting the deepest left child of this tree. So we are setting that index pointer to 1, as this will be the first element in the in-order traversal output list. The index is greater than 0, then we keep incrementing. Then I check whether the index is equal to the k. Then we return that current root node's value as the kth smallest element. Otherwise, we process the right subtree of this root node. Next, I am going to run the test cases. Okay, good, accepted. Next, I am going to submit this program. Okay, cool, it's accepted. Let's do the code walkthrough with this. We have this input and the expected kth smallest index is 2. So first we call this kth smallest helper with index as -1 and k is 2. So first we hit the root node 10. At that time the kth element is set to -1 and the index is also -1. So first we check whether the root is not null. So we try to make the kth element smallest helper with for the left child, and here it comes. So once we enter this frame, we again initialize that to -1. Root is not null, so we are entering. We try to process the left sub child. So this left child is nil. This point, this is nil. So we return the -1 here. So this condition is also not met. If the index is less than 0, this is the very first time we seeing the left child without a left subtree. So this means we are seeing the deepest left child. So in this, if we keep going, this is the child which do not have the left subtree. So then immediately we set the index to 1, because in the in-order traversal output list, this is the element, the very first element in that in-order traversal output. So we indicate that by setting the first element. Then we check whether that index 1 is equal to k, which is 2. It is not. So then we try to process the right element. So we call the kth smallest helper to make this call, and when we reach here, we try to make the kth smallest helper for the left subtree, which is null. So we are hitting here, and the index is greater than 0. We increment, it will become 2, and the index is equal to k. So we are returning the root value, which is 7. So this is the expected output. Next, I am going to do the time and space complexity analysis for this solution. Okay, let's do the analysis with this input. So this input has 4 elements. So depending on the what smallest element we want to look, the number of times the recursive call made varies. For example, in the case of 2, we have to make 3 recursive calls, and each time we have to make these processing to check whether we are seeing that left side first or not, and then we are comparing the k with the index. And if the element if we are looking for 4th smallest element, which is the last, then we have to traverse the entire tree. So the time complexity is eventually order of n in the worst case scenario, where the element to be found is last element in the in-order traversal output list. And with respect to the space complexity, it is order of log n. So at any point of time, the maximum number of frames to traverse the entire tree is 2, which is log n base 2. In this case, log 4 base 2, which is 2. So we have maximum 2 frames active at any point during the execution of this procedure. So space complexity is order of log n. Thanks for watching this video. Have a great day.